Hello, hello, check audio.
everyone. Welcome to Day 5 of Faculty Development Program. Good morning, everyone. Welcome to Day 5 of Faculty Development Program. National and international conferences and delivered over 100 invited lecturers at FDPs and workshops. As a dedicated mentor, he has successfully guided 13 PhD and 2 postdoctoral scholars. Additionally, he has organized 8 national and state level workshops on econometrics and statistics and has served on various university committees. We are honored to have him with us today, sir. We welcome you, sir. So the floor is yours.
So you can hold this. Right. 1 minute. Yeah, you can speak to. Yeah, you start here. You can speak.
Share market.
What?
PPT here.
PPT person.
Yeah, PPT file folder.
Good morning, all. Uh, okay. Today, my lecture is on the statistical tools for quantitative data analysis. And before getting to the tools used by researchers to analyze the quantitative data, as all of us knew that the most demanding course in recent years throughout the world is data science, data analytics. So I don't want to get into that part of discussion on why the data science is gaining importance in the last few years. And that consists of different say disciplines starting from data, then statistical methods. So it also consists of mathematical models, computer models, and so on. So if you just mix all these different disciplines, so that is data analytics. So because of the availability of the mountain of data, and also because of development in the models both in mathematics as well as in statistics, along with the advancement of computer for computation purpose. Okay, so we have that data analytics, and we are so familiar with that big data analytics. So that is the data is used in nature to analyze that data. We need different models for that. So therefore, say that data science is gaining importance due to because of also, so this is the era of information. So therefore, so the data analytics are the main purpose of that data analytics is to examine and to gain some knowledge related to the hidden information in the data. So this data analytics transform the data into information, and that information is needed for us as researcher to answer for the questions which we have raised in our research work. So by making use of that information from our raw data using these methods of data analytics, so including statistical methods, we are able to answer for all our research questions. And similar to the steps involved in methodology of say economic methodology of research, methodology of research, even in case of data analysis or using any statistical tool, including data analysis. So we have some steps. So the first step, even in case of this selection of any statistical tool or using statistical methods for our analysis of the data, so we need to first identify the issues. So those issues are nothing but the research questions which we have raised in our research work. So therefore, selection of any statistical method to get information from our data, the first step is identification of the issues. So once the issues are identified and based on that issues of our research work, so then we should have to check whether the data is available to answer for that research question or issues. So if the data is not available to answer for related to particular research question or research issues. So once we have checked whether the data is available related to our selected reasons, we should have to decide the appropriate method to analyze that data and to answer for that particular research question. So once we have decided the appropriate or suitable statistical method to analyze that data which we have collected in the second step, so then we should have to apply that method. So by applying that method, then finally we will get the results. So by making use of that results of that method, so we have to evaluate or summarize, and also finally we should have to communicate the results which we have obtained by using any statistical method. So data or the summarize the variables. So there are different statistical tools like graphical representation or tabular representation, and also some numerical summary statistics like measures of central tendency, measures of dispersions. But summarize our data. These summary measures are the typical measures or that provides us some typical information. For example, if you have a data related to the income of 100 households, so the 100 households have the different levels of income. So by using that raw data or the information about the 100 households regarding their income level, we are unable to get a meaningful interpretation or information from that. So if you use the summary measures, so for example, if you calculate the average or the arithmetic mean for that, that gives you a typical value, a summary value. By using that summary value, we can get some information. So though the value of that particular variable income that varies from one level to other level, but on the average, all the families are having a given level of income. So how many families are above that income or how many families are below that income? So this can be interpreted only based on that calculated value of the arithmetic mean. So hence we just get a summary of that. So that's why one of the purposes of selection of any statistical tool is to summarize the data. And the second one is, so instead of having only one variable, for example, if we have two or more than two variables, so then our purpose might be different, like identification of the relationship, whether the variables are related or not. If they are related, what kind of relationship among them, like whether they have a positive relationship or a negative relationship. So if the purpose of your research work is related to this identification of the research problem, so then we have to use some specific statistical tools. And also, in some cases, our purpose is to compare the variables, whether the one variable we have chosen is greater than the other variable or lesser than the other variable, okay? Or even identification of the difference between those variables, whether those variables are the variables we have chosen, two or more variables we have chosen are equal or not. Say, for in some cases, we also have these purposes. So then we have some specific statistical methods in such context to choose. Then the other purposes of using statistical methods are, so instead of only identifying the relationship, we might also have an objective of measuring the causality. Cause and effect are the changes in your focused variable, okay, is because of the other variable. So in this case, we have a set of variables. In that set of variables, okay, we have to choose one or few as the dependent variables, and the other set of your variables has to be considered as independent variables. So whether these set of independent variables influences on your focused dependent variable or not. So if one unit increase or changes in the value of your independent variable, how much your dependent variable varies. So if your purpose is to analyze this kind of cause or and effect kind of relationship, so then we have to use some specific statistical tools. And in some situations, our objective or the research issue is also to identify or to analyze interdependence, because in some cases you are unable to divide or group your variables as dependent and independent variables. So for example, if I take a general example, like, so in writing an equation like, so y is a function of x. So if y is a function of x, so then we have a causality relationship that x causes y. That is, any changes that has been taken in y is due to because of variations or changes in x only. But in some cases, the relationship is also reversed. For example, if I take my own example or economics from the economics like this. So we are all familiar with economic growth. So that economic growth along with other variables also influenced by foreign direct investment. So, and as the empirical works also shown that, so the foreign direct investment also depends upon the economic growth. A proxy for measuring the economic growth is GDP. So then, so if I write a function like GDP is a function of foreign direct investment, as well the foreign direct investment also depends upon the economic growth or the GDP. So then I have an interdependency between the economic growth of a nation and the foreign direct investment. So then I cannot use a cause and effect type of relationship more specifically. So specifically, and also we have such several other factors where the interdependence variables are there. So therefore, the another purpose of selection of any statistical tool is to measure such interdependence. You are familiar with so that like the cluster analysis or multidimensional scaling or factor analysis. So these are all more specific statistical methods which are used to measure the interdependence among the quantitative variables. Similarly, there are qualitative or non-metric interdependence methods are also there. And the last but not the least, for a quantitative variable related, the tool is forecast outcomes. So that means our purpose also in case of business, in case of economics, even in case of other disciplines, our purpose is to predict or to forecast the future value of a chosen variable. So that might be the another purpose. So that's why, so these points gives us in any research work, in selection of a statistical tool that based on the purpose of the research we are doing. So based on that purpose of the research, we have to select a specific statistical tool, and these are the different purposes, okay, in where we can select the statistical tools. So yes, earlier I've told you that, and all of us knew that. So this data analysis as a part of any research work is only one of the steps out of several steps. Probably it is not but one in majority of all the steps before writing the report. Next. Okay, then come to the statistical criteria for choosing or selection of any statistical tool are given here. So the statisticians were identified the 4 important criteria for choosing or selection of a statistical tool for analysis of our data, irrespective of the types of the data. So the first one is the number of the variables for our analysis, and the second criterion is the measurement scale of the variable, and the third one is the purpose of the analysis, and the fourth criterion is whether the statistical tool which we will need to select for our purpose as assumptions or not. So in case of the numbers of the variables, all statistical tools are broadly grouped or divided into 3 statistical tools: univariate, bivariate, and multivariate. So the univariate, that is, you have only a single variable, and your purpose is to analyze only that uni or a single variable, like only to summarize that particular variable or only to describe that particular variable. So we cannot do any further analysis beyond that description or summary analysis for a univariate analysis or for a single variable. And the second one is the bivariate. So as earlier we have noted that to identification of the relationship, comparing the variables, cause and effect type of relationship, and so on. So we need at least 2 variables. So if your purpose is to compare or to identify the relationship or to make a difference or identifying the difference and so on, so then you have 2 variables, and the analysis or the statistical methods related to that 2 variables are known bivariate analysis. And the third and the most important, and which is more practicable or practice compared to those 2 other methods, are the multivariate analysis, because in any research, okay, we have more than 2 variables, and even for the 2 variables, so we can do all the earlier analysis or the purposes we have noted. The 3 or more than 3 analysis related statistical methods are known as the multivariate statistical methods. then the second criterion to select any statistical tool is based on how do we measure our variable. It is a kind of statistical measurement. Based on that statistical measurement, we have 4 types of variables. You are familiar, I hope. The one is nominal, the second one is ordinal, the third one is interval variable, and the fourth one is ratio scale variable. Because this idea is, or the criterion is, another important criterion for selection of any statistical tool, because there are different statistical methods developed by the statisticians based on the type of the data, based on the measurement scale of the data. So the nominal variable is the lowest scale in that measurement. So it is purely a qualitative one, which has only a nominal kind of information we have, like it has only in terms of characteristic, or in terms of attribute, or in terms of quality, like gender, religion, caste, region, and so on. So which cannot be numerically measurable. So that's why a variable which cannot be quantifiable, a variable which cannot be numerically measurable, that is a nominal variable. And there are some nominal variables, they have some additional characteristic or attributes where that variables can be classified or ordered. So therefore, those variables as ordinal variables. So like the level of satisfaction, or in case of an organization, like the job category. So starting from CEO to unskilled worker, or the level of education. So from primary, secondary, or college education. Okay, like that, we can have such several variables where they are also nominal variables, but there is a meaning in ordering them. So those variables are called as ordinal variables, and there are separate statistical tools related to that. And the next two are related to measuring them. That means they are quantitative in nature. We are able to measure quantitatively, and they are continuous in nature. But the difference between those two is, in case of an interval variable, okay, so the nominal meaning is meaningful. The ordinal definition is also meaningful for this, and as well, also the interval is meaningful. In case of ordinal variable, the interval, the distance is not meaningful. For example, if I take that satisfaction related example and assigning some codes or the number for that, so highly satisfied 5, satisfied 4, neutral or no answer 3, and not satisfied 2, and highly not satisfied 1. So now I have given us numbers for this with a scale, Likert scale, for example. So then the 5 doesn't mean that the person who was said or opined, I am really satisfied with that particular product, doesn't mean that. So he is 5 times satisfied compared to the person who said, I am not highly satisfied. So that means the interval is not meaningful. The distance between that orders is not meaningful. So, but whereas in case of interval variable, that is also meaningful. So that is the difference between an ordinal variable and a quantitative variable like interval variable. But there is that it has no zero origin. So we cannot have a variables which are measuring in terms of the ratio. So if we use the two variables and express that variables in ratio form, so then the ratio is also meaningful. For expressing a variable in terms of a ratio, the zero origin is important. So that is the difference between interval and ratio scale. But in all statistical purposes, these variables are considered as same variable as a scale variable, not much difference between these two for analysis and application purposes. So that is the second criterion to select any statistical tool. The third and the fourth one related to a statistical criteria. Earlier I have said some purpose of selection of a statistical tool based on your research analysis. So like summary or identification of the relationship, comparing and so on. They are related to purpose of the selection of the statistical tool based on your research analysis. But whereas this purpose of the selection of a statistical tool is related to a statistical criterion, that is whether your purpose is only to describe or to draw inference. So because whole statistics has classified into two broad branches. One is the descriptive statistics, the other one is inferential statistics. So that's why your purpose is only to describe the data, summarize the data, then that is called as descriptive statistical analysis. But the most appropriate in practice for all of us, in majority of the cases, out of these two methods are, one is, that is the inferential statistics, because the inferential statistics is a branch of statistics where our purpose is to draw conclusion or inference related to the population or population characteristics based on the sample evidences. Since especially in our social sciences, in most of the cases, our research work is based on the sample analysis, based on surveys, sample surveys. So therefore, we have only a information from part of the population. For example, if I take, my purpose is to say analyze or related to a marketing analysis, like so the consumer preference related to the products of a particular company, then I will choose only few customers, or for example only 100 or 200 or 500 customers in Mysore city. But the population is large, the customers or the consumers of that particular product is large. So my information or the information which I have collected to analyze my issues or the research questions are only a part of the population, and any estimation and any information which I will get by using these statistical methods are only related to that 500 customers or the consumers I have selected. But my research question is not related to that sample units or 500 customers. I have to draw conclusion, or I have to say validate my results with that old customers or the consumers in Mysore city. So that's why in case of inferential statistics, so we have to draw conclusions or the inference about the population characteristics based on the sample evidences. There are large number of tools. Of course, the most of the statistical tools are related to that inferential statistics rather than the descriptive statistical methods. And the last criterion to select any appropriate statistical tool to your analysis or the research work is based on the assumptions. As earlier I have told you that, so there are, of course, if you take this parametric test, so almost all these parametric tests are based on some assumptions. So, and these parametric tests are derived from the probability distribution theories. So you are familiar with those distributions like normal distribution or T distribution, chi-square distribution, F distribution, and so on. Okay, so out of this, okay, there are distributions. Like if you take the normal distribution that based on some assumption. So, and it has some parameters. Like there are two important parameters. The one is the mean. The second parameter of the normal distribution is variance or the standard deviation. So, similar to this, in case of the T distribution also, we have the same kind of variance and the mean. So that's why they are called as parametric distributions, and all the statistical tools come under this parametric test assumes, so the variable which we have chosen for our analysis assume it to be normally distributed, and if you have two variables, the variances of those two variables are equal, and so on. So therefore, so the parametric tests are based on some assumptions. So if these assumptions are not holds good for your variable, then we have to use non-parametric test. This is the one context of use of non-parametric test. The second one is, so if your variables are nominal variables, if your variables are ordinal variables, in case of ordinal and nominal variables, we cannot use parametric test. We should have to rely only on non-parametric tests. So that's why everyone or every researcher must have to have these known to these four criteria for selection of any statistical methods. Next. So these are just descriptions related to those points thus far we were noted. Next, please, you go to one chart. Next, please. Next. Okay, next. Okay. So now I have 3 slides before getting to my say the hands-on session related class. So the first one is it is the selection of an appropriate statistical method if we have one variable. That's why univariate procedure. So, and all the earlier criteria were included in this slide for selection of an appropriate tool if we have only one variable and the purpose is only to describe, and also along with testing hypothesis or in case of inferential statistics. Okay, so the first, we have only one variable. So then the second, as already we have noted, the second criterion to select any statistical tool based on measurement scale of the variable. That's why, as earlier I have told you, that interval and ratio scales are merged, considered as a single variable or the measurement scale. And the second part, ordinal variable, and the third one is nominal variable. That's why the second is the measurement scale of the variable. Then the third, related to the purpose of use of this univariate technique, whether it is for descriptive purpose or it is for inferential purpose. Okay. So then in case of descriptive type of analysis, if you have a interval or scale variable or ratio scale variable, then the appropriate method is arithmetic mean. And to measure the dispersion or variations in the data for a univariate variable, if it's a quantitative or a ratio interval is standard deviation. And if your chosen variable is an ordinal variable, then the techniques are different. So for example, if it is for descriptive analysis, we have to use median for this, and whereas for variations, we have to use interquartile range. Whereas for a nominal variable, for descriptive purpose, we have to use frequencies, absolute or relative or percent frequencies. And if we have only one variable, also we have formulated a hypothesis related to test that one. So then that comes under inferential statistics. And the two most popular tests of inferential statistics to test a hypothesis for this interval are the scale variables are z-test and t-test. It is a large sample test and the t is a small sample test for practical purposes to my knowledge. So we use only t-test. So because there is not much differences related to that probability value or the table value between z and t when we have 30 or more than 30 observations. So if you just look that t table value for 30 degrees of freedom, so you will get a value more than 1.96 at 5% level of significance. That's why after 30 observations, there is not theoretically difference between z and say the t-test. That's why, so in almost all statistical packages, we have only t-test related results instead of z-test. So then if our variable is an ordinal variable, so then we have to use non-parametric test as just we were noted. So then for a single variable to test any hypothesis related to your ordinal variable is KS test, Kolmogorov-Smirnov test. And if your variable is a nominal variable and you have only one variable, then the appropriate and only one test that is available is chi-square test. Okay, so that's why whether discussions related to this univariate process are related to the bivariate or multivariate process, the same criterion we have followed here. So based on that, so the statisticians have identified specific tools to select and analyze our data. Next. So the same criteria are used also, but only the techniques are changed. So in case of a descriptive analysis for two variables, if our purpose is to measure the relationship, as all of us knew that if the variables are say quantitative or interval or scale variable, the most popular measure is linear correlation coefficient. That is the Carl-Pearson coefficient of correlation. So if our purpose is to measure the cause and effect type of relationship, the most popular statistical tool till the date to measure that cause and effect type of our causality is the regression analysis, and that is simple regression here because we are here only two variables. So one influences on the other variable. So if our variables are ordinal variables, so then instead of the Karl Pearson coefficient, we have to use the rank correlation coefficient of Spearman. So if our say variables are having more ties, then we have to use type of the correlation analysis. And as usual, all of us knew that if we have two qualitative variables, then the appropriate measure of measuring association between those variables are contingency tables or test of independence and so on. And if our purpose not only to measure this type of relationship among the two variables irrespective of their nature, so also having hypothesis to test, then in case of two variables, interval or ratio scale variables, no change in the test. Earlier also in single variable, we have Z and T test. Here also we have Z and T test. But if the variables are ordinal, then there is one change, that is MWU test along with that KS test. So we can use KS or MWU test to ordinal variables to test the relationships. Okay, then the last, even for two variables, so we can continue with that chi-square test. Okay, so this is related to the bivariate procedure. Then the last but not the least, and this is more complicated because always, as even in our theories, we know that as the number of the variables we goes on increasing, so our analysis also becomes complex. Even theoretically, we have noted that. And I hope in all our theories, to related to my own domain of knowledge, that is economics. Okay, in all our theories, okay, we discusses only the relationship or causality, whatever it is, among the variables by taking two variables at a time. Two variables at a time. So if you just extend our analysis with additional variables, the analysis becomes complex. Similarly, even in case of statistical analysis, okay, we have only few such statistical tools related to univariate or bivariate. But whereas in case of multivariate analysis, we have further sub-classifications, subdivisions, along with the earlier criteria which we were noted. So this slide gives us the important statistical methods or the statistical tools used for multivariate analysis. Okay, so before getting to that earlier type of criteria analysis, so in case of multivariate analysis, all multivariate analysis are broadly classified into dependence techniques and interdependence techniques. The meaning is, in case of dependent techniques, as already I have told you, that the purpose is to measure the causality, cause and effect type of relationship. And whereas in case of interdependence, the purpose is not to measure the cause and effect, only to measure interdependency of our selected variables. Within this dependence techniques, now again we have the number of the dependent variables in our analysis. If we have only one dependent variable, then it is one dependent variable related techniques. We might also have a set of variables instead of one dependent variable, that is several dependent variable case. Dependent techniques, one dependent variable, several dependent variable, because the tools changes from this to this. For example, if the dependent we have only one dependent variable, now we come to that earlier context. So that is whether the dependent variable is your metric is synonymous to that quantitative, and that is synonymous to our interval or scale variable. So if your dependent variable is a scale or interval variable or a metric variable or in general a quantitative variable, and these are the most popular methods like multiple regression analysis. Also we have a regression analysis, that is simple regression, measuring cause and effect type of relationship. The same can be straightforwardly extended to any number of variables for measuring causality of a single dependent variable, that is called multiple regression. Along with that, the conjoint analysis. So this conjoint analysis is more popular in case of marketing analysis, measuring the different characteristics, socioeconomic characteristics on brand preferences of the customers. So then if your dependent selected variable is a non-parametric variable, non-metric variable, a qualitative variable, so then the discriminant analysis and the discriminant analysis that say discriminant or divide. So the similar the divide the heterogeneous variables and make the similar objects into a particular group. And the one more popular measure is a logistic regression, a logit model where the dependent variable is a qualitative variable or a non-metric variable. In case of several dependent variables, again, the classification is all dependent variables are metric or all dependent variables are non-metric variables. So it is an extension of ANOVA. Okay. So even you can include that ANOVA under the metric dependent variable, and this is a MANOVA. So this, in case of MANOVA, instead of single dependent variable, a quantitative in nature, we have a set of dependent variables. And the other one is canonical correlation. So this canonical correlation is somehow related to that multiple regression analysis. In case of multiple regression, we have only one dependent variable, but whereas in case of canonical correlation, we have two or more than two dependent, say, variables, metric variables. So non-metric are, so we can also use the canonical correlation for a non-metric purpose also. And the other one is a dummy variable. So dummy in statistics means a number, a code is assigned to a qualitative variable like 0 and 1. So these codes are dummies, proxies, surrogate to represent some attribute, whether it is present or not. So those models are called as dummy variable models. And whereas in case of interdependence techniques, so if our purpose is to measure the interdependence among the quantitative variables or metric variables, the two popular measures are, as earlier I have told you, cluster analysis and factor analysis, and also the multidimensional scaling technique, both which is a measure of metric and the non-metric type of variables. And the other one is correspondence analysis if our variables are purely qualitative or nominal variables. Okay, this is about a brief discussion and an introduction to the criteria for selection of statistical tool for any purpose, irrespective of the research questions and the research disciplines, and also some important statistical tools related to that bivariate, univariate, bivariate, and multivariate analysis. So with this brief discussion related to the statistical tools and their classifications and the purpose of use and so on. So now let us have an hands-on session related to few of these statistical methods in the next part of our discussion. We have another almost 2 hours. So in that 2 hours, so I will show you how to use SPSS, starting from the one way, that is one mean test. Then I will take 2 mean test of comparisons, and also I will extend that into ANOVA of one-way and two-way analysis. So then I will also show you using SPSS for estimation of the correlation and regression, both for, of course, regression for simple regression analysis and multiple regression analysis. And our focus much is on not only to get the results, but the context of use of these statistical methods, as well as how to interpret the results of the SPSS for all these statistical tools. Okay, so now I need that SPSS. Okay. Okay. Uh,
Just try to formally take this step.
Ah.
Then we send the data, try to open it.
Okay. 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 So now we start our hands-on session related to some of the statistical tools and using them through SPSS. So now I request all the participants to open first SPSS package. So then before, of course, importing the files which are already sent to you through the email for the hands-on session. So let me first have few words related to SPSS, and I hope Srinivasa Kote sir will have classes related to the basics of statistics in the next classes. So hence I don't want to get into that basics of say the use of SPSS. So I will just focus more on the use of SPSS for the tools thus far we were discussed related to some parametric or only quantitative type of tools thus far we were discussed. So the page which has been, or the window which has been opened now on the screen is looking like your Excel sheet. So we are all familiar with that Excel sheet, but there are differences because in our Excel sheet, the menus are somehow different compared to this. So in case of this, here we have the menu buttons like the similar to almost all Word related menus like file, edit also here. But the next menus are the analysis related menus. So like data or transfer. Next one is the analyze one, and the one more is graph, like that. Okay. So below that we have some icons. So those icons are, we can directly use these icons for some specific purposes. So probably that will be covered by Melkote sir. Okay. So and now the window that has been opened is a data view, which is in the left bottom corner. Okay, data view. So this data view is a window where our data appears. So that means, so we can directly input our data into this sheet like your Excel, or we can import the data from any other external sources, from Excel or from other sources, SAS and also others, software, statistical softwares. And one more button, okay, nearer to that data view in the left bottom corner is there. So if you click on that, you will have a new window. That new window is variable view. So that means in any information which we have gathered, and that information as, or the variables has the characteristics like we have to give a name for the variable, and that variable has different characteristics as earlier we have noted, like say the whether the variable is a quantitative variable or a qualitative variable, or we are entering that variable in a numeric form or in a string form. Along with, so we also have to specify whether our variable is a nominal variable or an ordinal variable or a scale variable. So all these descriptions related to the data is in this view, that is variable view. So for example, the first column of this window is the name of the variable, because you should have to give a name for your variable. So that's why the name of the variable is the first column. So the next column as the type of the variable. That type, as earlier I have told you, that whether your variable is in a numeric form or in a string. String means in a purely qualitative in nature. So you should have to select one out of these two. So the third one is, this is related to the width and decimals. So that is the column width, the decimals, whether your data as decimals or not. So for example, if I want to include inflation rate, for example. Okay, the inflation rate, I need to have that inflation rate, unemployment rate, and so on in terms of having decimals. Okay, so whether you have a decimals or not, that has to be specified here, or the number of the decimals, whether you have only one decimal, two decimals needed, and so on. So, and the label column that represent, you can fully describe your name of the variable there, because there is a limitation to use the letters to name the variables. But whereas in case of label, for example, like this, even you can include your whole questions which you have used in your questionnaire in the label. Okay, and you have to write a short form to that question as the name of the variable. For example, like name of the respondent, probably that is the first question in our questionnaire. Okay, you cannot give name of the respondent as full to your name of the variable. So you have given there only name, but as a description to that variable, name of the respondents can be included or written in your label form. So that's why the labeling your variable, describing your variable in an understanding way for you for further analysis. Then the values. So this is the coding of the variables. That means nominal variables, then ordinal variables. They should also be coded instead of, for example, gender. Now you can code that gender because the gender has two classification, for example, in your survey. So then male and female. So these coded values, for example, for nominal variables are arbitrary in nature. Arbitrary in the sense, for example, you can code male as 0, female as 1, and also you reverse. There is no change in that. But whereas for ordinal variables, you cannot do that. So that's why both for ordinal and nominal variables, if you want to code the variable, so then you have to use this. For example, if you select this, then if you have a variable, then you will get one new window there. There you are able to code that. So then if you have missing values, that means are missing observations, missing values for a variable. So all those are entered there. That means you have 50 questions. No guarantee that each and every respondent answered all the 50 questions. That means for 50 variables. For one of the questions, for example, only 40 were answered. Then 10 are missing. So there you should have to mention, or your mentioning means you should have to give a specific number for that. For example, in case of SPSS, so if you enter there 999, for example, so that 99 as considered to be a missing observation or a missing value for that particular variable. So because for each variable you might have missing or not missing, where if a variable has a missing observations or missing number value, you should have to click that and add that 999. That 999 cell is considered as missing, that is not further used for any calculations. For example, like this. So you need to calculate arithmetic mean. Okay, you have 50 samples related to that particular question. For example, like this. So we have 50 respondents, collected consumption expenditure of that 50 respondents. 5 respondents are not given answer. Okay, but if you are not selected that missing number, actually you have 50 number of observations, your arithmetic mean calculated the total of that consumption expenditure of all the persons who are given information divided by 50. But actually the denominator should be 45. So if you are not entered that missing number, okay, so then probably your calculated value of the mean is wrong. And even in case of your missing numbers, so if you get a frequency, you will have missing numbers is appeared with that one. Okay, so that is the meaning of missing number. And the column width, so that is not much important. Alignment left or right, so you are familiar with that. And this is the measurement. So that is the measurement scale, the second criterion which we were discussed. So there are 3. One is nominal, second one is ordinal, and the third one is scale variable. You should have to first check that column, most importantly, whether the variable you have chosen is one out of these 3. Okay, this is related to a brief discussion related to this description of your variable in the data view. The most important are you have to give a name for your variable, Then the second one is type of the variable. You should have to select radio button within that, whether it is a string or a numeric. Okay, that is important. And the other one is, so the last column, that is the, whether it is a nominal variable or scale variable. These are the three important descriptions which you needed to use or for further analysis before getting to that further analysis. Okay, this is a SPSS, the output will appear in separate window because there are different packages. So in case of SPSS, we have two windows. The one is this data editor window. The second one is output window. All our outputs are appear in other window. So normally I use one more which is more appropriate for our analysis in economics, in econometric analysis, that is stata. I normally use in our classes. So that stata, in that stata, the output is appear in the same main window itself. Okay, so that differs from one package to other package. Okay, this is about a brief discussion related to that. So now let us start my session of this hands-on experience with testing one mean test. Okay, let us just take a context of use of this one mean test. That is the circumstances of use of this. So all of her, I hope, familiar with one report of a sample survey related to health status of the Indian households, National Family Health Survey. Okay, in that National Family Health Survey, in the recent report, around 70% of the pregnant women are having anemic problem. That means, stop madboda. Okay, so then, okay, we will have a 10 minutes break. So then we will continue this, use the context of use of a statistical tool and data for that, and how to use SPSS to answer for that problem. So that will be our discussions in the next 1.5 hours. Sorry for some technical issues. Now let us start with the first hands-on experience related to testing the mean of the populations. So as I have said earlier, according to that NHFS report, around 70% of the pregnant women are having anemic problem. Means their the blood level that has been prescribed by the WTO is the HB level is 12, you know. So if that HB level of 12 is less than that prescribed 12 HB then percentage, then that is called as the problem of anemic woman. Okay, and it is a report related to all India level. Say if your purpose is to test whether in Mysore district the percentage of anemic women are equivalent to India level or not. So if your research issue is related to comparing the percentage of anemic pregnant women in Mysore district with the India level, so now this is called as one population mean test or one mean test, because you have a single variable, that is the anemic problem related information. So then you have, let us assume that you have collected the information related to that HB level from 100 women. Okay, then you have calculated the HB level of this 100 women, and that 100 women's your sample value or the 100 women's HB level on the average is, let us assume that it is 60. That is, in Mysore district, 60% of the pregnant women are having that anemic problem. Whereas in case of India level, it is 70%. So now you should have to validate your results. That is, whether it is really 60% in case of Mysore district, showing a better performance in case of that HB level in Mysore district compared to the all India level. So, and of course, any hypothesis testing is a test related to testing whether our results which we have obtained from our sample evidences are similar or equivalent to the population values. So therefore, this 10% of difference between our sample value with a population value, we are considered that as an hypothesized value or a population value of 70%, 10% is different. So whether this 10% difference is statistically significant or not. So in other words, whether this difference of 10% is due to because of a chance or due to because of a real difference. The chance means, so we have selected the sample, though it is randomly, but they are possessing some characteristics which is similar to the population. In such a case, you are unable to reject your null hypothesis because there is not real difference between your population value with the sample value. So if that is real, that is the 10% is a real difference, it is due to because of the various factors which are responsible for having lesser number of percentage of pregnant women with that particular value. So then we call it as a statistically significant difference. So to answer for all these questions, we need to use a statistical test, and that test is one mean test. That means we have a hypothesized population. Okay, so then we are also in a value related to that hypothesized population, and we are comparing our sample value with that hypothesized value or a value which is already done or empirically accepted value. So they are the case, but here I use for this test and for the next two tests. So that is related to one mean test, two means test, and one more is related to ANOVA test, an extension of this testing means of 3 or more than 3 populations. Okay, I use a data related to, say, the self-help groups. So we are all familiar with that self-help groups. Okay, and one of the indicators of that self-help groups is the amount of savings. So now I have a data related to that savings by the selected self-help groups, and also for my further discussions I have one more variable. That variable is social category of that self-help groups, classified as like the self-help groups belongs to scheduled caste, scheduled tribe, and the other categories, OBC for example. Okay, so that will be used for the next purpose, or using or testing 2 means or the 3 means or ANOVA. But in the first case, I had the data related to the savings of all the self-help groups. Okay, the data is on the savings. So as earlier I mentioned that we can directly input our data or type our data into the SPSS. But normally what the researchers do is they have data in other sources and more specifically in Excel. So now I have my data in Excel sheet. I import directly that Excel sheet to SPSS. So for that, the steps are as follows. Okay, first you should have to click on file button. Okay, you put the cursor on the file button and just click on that file button. A pop down menu appears there. A pop down menu. In that pop down menu, the third option is import data. Okay, just put your cursor on that import data. Then if you just put that is your cursor on the import data, then one right pane has been appeared there. In that, you should have to click on Excel. So even you can have CSV data, and you can directly import data from Stata, SAS, the other statistical packages. So here I have data in Excel sheet. I just select that. Even probably in your system, you have the data which I have sent yesterday. Okay, you have to click on that Excel. Once I clicked on that Excel sheet, one new window appears. So in this new window, I have to open the data. Since of course, already I opened few minutes back, that's why directly it opens the folder where my data is situated. Probably I was sent a folder name as sent Philomena. Okay, so you have to click on that sent Philomena first. Then all these files open there. Okay, so I have several data files here. Okay, now the appropriate one for the test out of these is the last one, that is t-test. Okay, you just click on the t-test. Once you click on that t-test, okay, so the file name automatically appears there. Earlier the file name cell was empty, but if I just selected this or click on this, it was automatically appear there. That's why you need not to type the file name or so on. So then you click open. I repeat, file, import data, Excel, then within this open data, so you should have to click on t-test related file. So then now click on open button in this window. So once you click on this open button, so whether it is opened in your system? No, not operating. Oh, it is hanged. Whether it is opened in your system? Yes, sir. Okay. Yes, sir. Yes. Only one column. Yes, sir. So, but it is not operating. One. Okay, okay, okay. Yeah. Okay, sir. So actually, in that particular sheet, probably I had the data in 4 sheets. So since the first sheet is automatically imported, so that is the file which I have required. But there are actually the next title, the second sheet title is two means test. So then the one more is the say paired test data. The another one is ANOVA data. Okay, since okay. So now, for example, the worksheet is this. So if you want to select a separate different sheet instead of first sheet, so there is a down arrow mark at the right part of that cell. You just click on that, all the active sheets are appear there. So like one sample t-test data, two sample t-test, ANOVA, two sample unpaired, paired test, like that. So I have different types of data, or the data for different techniques which are in the same single Excel file. And now I need only the sheet 1, that is one sample t-test. Okay, so then you need not to do anything here. Okay, so next is, in case of my default page, read variable name from the first row of the data is automatically selected. That is most important. So if that is unmarked or not ticked, then your name of the variable is considered as the data itself. Then all your variables become considered as string variables, as earlier I have told you that. That's why you should have to make sure that whether that first, okay, this button is ticked or not, selected or not, and these things are not important much. Okay, fortunately it is by default selected. So then after this, you just click on OK button. So once you just click on that OK button, so SPSS import the data from the Excel sheet. Now here you have seen okay. So this is the savings. As earlier I have told you that it is related to the savings. So to know the number of the observations, you have to scroll down. For example, I had 90 observations. That means I have 90 self-help groups. From that 90 self-help groups, we have collected the data related to savings. Okay. So then all the statistical tools which are inbuilt in SPSS are in the tab named analyze. Okay, so you have to go to that analyze button or select that analyze button. So click on that analyze button. Once you just click on that analyze button, one more pop down menu appears. So in that pop down menu, all statistical tools are there. Okay, so there are different two techniques, and now we should have to identify which one is appropriate. For example, if you require descriptive statistics like only frequency table, whether for a single variable, for any number of variables. So there you see frequencies. Then the next is descriptive statistics. That gives you the value of the arithmetic mean, standard deviation, minimum value, maximum value of your selected. You need cross tabulation. So if your two variables are nominal variables, okay, then need a contingency table. So then you use that button. Okay, so I will show you, if possible, where it is applicable for the next purpose. So then, but for me, in this case, the one tab with a name called compare means, because this compare means is comparing the mean values of the populations. So if you just put your cursor on compare means, one more right menu appears, and comparing the mean values, whether comparing the mean values. Okay. So now you should have to click on one mean t-test there. One mean t-test. Okay. Click on share. Yeah, one sample t-test. Okay, they are one and the same. Sir. One sample. So we are testing mean. It's okay, sir. Okay. So one sample t-test. One sample t-test. So then if you just click on that one sample t-test, one new window appears there. Okay. So in that window, you have two panes, two parts. One is related to the variables we have. Since in our sheet or the worksheet, we have single variable. In the variable pane, you have only one variable. So, but actually, if you have several variables, all variables appear there. But out of that one, you should have to select one for which you intend to test. Okay. So this is the scene. Okay. Here you have two panes within that windows, left one and right one. So these are the saving is one of the only variable we have. So then you put this to the test variable side. You just click this arrow mark in between, in not only here, in all these graphical user type of use of spaces, because there are three types of all statistical softwares. One is, this is called as menu driven, because we are selecting some menus and clicking them, and we will finally get the result. The second one is giving command. So using command also we will get the results. The final one is writing syntax. So of course I am not familiar with that writing syntax because I have no knowledge of that computer language to write those things. But whichever the method you use, the results are one and the same. But since we are learning this, and also we are not the students of computer science, so what we require is only we need results for our analysis. Whichever the method we are familiar, we will use that and get the result. Okay. So then here OK button, then you will get a result. Output comes, output in the other window. Okay. So in that output, okay, in that output, yeah. ಬೇರೆ ಯಾರ್ದಾದ್ರು ಇನ್ನೊಂದು ಕನೆಕ್ಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗ್ತದ ಸಿಸ್ಟಮ್ ಅಲ್ಲ, ಇದು ಬಹುಶಃ ನೆಟ್ ಪ್ರಾಬ್ಲಮ್. ಹೌದಾ? Okay, you will get a table there, you know. Okay, that table is the results of that t-test. Okay, so in that there you will get the mean of that particular variable. and a t value for that, a level of significance for that. Okay. Okay, will you please give? Okay. Oh, sorry. So here we have different tables. Okay. The first table is one sample statistics. That gives you the number of the observed n represent. We have 90 households as already we have noted. Then the mean value, though the saving levels of that 90 households are different, but on the average per month their savings is 2026 plus 2.6.7, that is 2026 rupees per month, for example. So then the standard deviation value is given. So I hope you know the basics of testing hypothesis, and also you know the formula to test that. So that is T is equal to x bar minus mu divided by standard deviation by root n. So that means we required three informations to calculate that test. The one is we need the mean value of the sample, and we are comparing that with the population value. We should have to take the difference between those two, that is x bar minus mu. So that difference, whether the difference is real or not, statistically significant or not, that decided by two things. The one is the variations. For that we are using standard deviation, and that also varies with the number of the observations along with zero value. So even you are putting zero or not entering that number, you have got a result for that. That's why the results given by any statistical packages is not always appropriate, because you must have to know how to use that, what should be entered to that. Okay. Therefore, if you just input any data to XSpaces or any statistical package, click some buttons there, that will give results. So therefore, this is not appropriate. So now I should have to use an hypothesized value because it is a single mean test. Whereas in case of two means or ANOVA test, you need not to, because your purpose is comparing two sample values. You need not to have an hypothesized value related to testing them. So therefore, here let us assume that we have to repeat the same procedure. You please repeat that. Repeat in the sense that, so there is one button there in the first window that appears after putting your saving values and the test variable. Below that there is a button. That tab or the button is test value. There you should have to mention test value. Okay, you please repeat this. Okay, please you repeat this. Go to once again analyze button, then compare means. Okay, one sample t test. Okay, already it is in the test variable. Now below that, as earlier I have told you that the test value is 0. So there below that test value is 0. In that test value, so let me write a number. This is an hypothesized value in this case. So let us, I am here hypothesize that on the average, the savings of these 90 households is 1,800. So this was assumed by me before conducting my research. Okay, that's why always we propose or state our hypothesis before execution of our research work. That's why now I am assumed that on the average, their monthly average savings is 1,800 rupees. Now, after this, you just click on that OK button. So once you click on that OK button, automatically the output window appears. Now you have the values. So under that table, test value is 1,800 rupees. Now we are comparing that. Okay, comparing that. So whether the average savings of these 90 households is 1,800 rupees or not. 1,800 rupees or not. So therefore, now you should have to look only the values like this. They are there in the table. T value is there. Then degrees of freedom is there. Level of significance is there. Okay.
Yes.
Okay. And
Yeah, you can use mouse.
okay. 1,800 earlier I have given. Okay, these are the results. Okay, in this result section, so what you should have to focus only on the T and the significance level. Okay, the T value is 5.423 and the significance value is 0.001. Okay, and in case of hypothesis testing, in all these statistical packages, they provide us the level of significance level related values. Based on that only we have to interpret. Actually, there are 3 methods of hypothesis testing or approaches to test. The one is confidence interval approach. The second one is test of significance or critical value approach. And the third one, and it is more popular in recent years because of use of this statistical packages, that is probability value approach. So it is a probability value approach because we are rejecting or not rejecting our hypothesis, which we have framed based on the observation of that probability value. So actually that SIG in case of SPSS, you should have to consider it as a probability value, but in all other statistical packages, it is not given as SIG, it is given as PROB, probability value. So which means that, okay, we have to compare that probability value with our level of alpha assumed. Alpha means the rejection of the true null hypothesis. The confidence was 95%. The rejection or the level of alpha was 5%. So if the probability value or the level of significance given here is less than that, say significance level, that is 0.05, we have to reject our null hypothesis. Otherwise, do not reject our null hypothesis. So therefore, here the probability value is 0.001, but our alpha level was 0.05. Since this SIG value is less than 0.05, hence we have to reject our null hypothesis. Therefore, to reject or not to reject, not only in this case, in all statistical analysis, we have to compare this value given by the statistical package with our assumed level of alpha, that is 5% in all the cases. And this is called as an observed level, because if you use critical value approach, you have to compare that calculated T value or the value given by the software with the table values. Since the table values are not shown or given by the statistical packages, we cannot continue with that critical value approach. Therefore, we have to use probability value approach. So if it is less than 0.05, you have to say it is significant at 5% level of significance. Okay. And this test is not much used in practice because as earlier I told you that always our purpose is to comparing the variables. Hence we must have to have two variables or more than two variables. But the basics is same. We just extend our analysis having more variables instead of only one variable. So therefore, let us consider an extension of this, that is two means test. Two means test. So which means that now we have two populations. So our purpose is to compare whether the means of these two populations are similar or not. For example, like this. So even for your work, like you have the income of two groups. Okay, whether the income influences on a particular variable. So we need not get into that variable or the influence related analysis. Here is you have two groups of people. Okay. For example, now you are comparing the income of households in Mysore with income of households in Bangalore. Okay, income of households in Mysore with income of households in Bangalore. So now I hypothesize that there is no difference in the income of households of Mysore and Bangalore. Okay, so now I need to test this hypothesis, whether my hypothesis is holds good or not. Similarly, here I have two groups of people related to the saving, because for convenience I continue with the same data, but the savings of scheduled caste households and the savings of scheduled tribe households. Okay, so one of the criterion or one of the characteristic, as earlier I have told you, that are the variable I have selected along with the savings is their social status. So now I am comparing the average savings of scheduled caste households and average savings of scheduled tribe households. Or in general, you have two variables. Your purpose is to compare the two variables. So now, okay, you go to that variable window. Okay, you click here, go to variable window. So now you should have to clear this. Okay, so for clear this data already, which is in the data editor, select that is clicking on the title of that variable. The whole data has been selected. Then right click your mouse and there is an option there, clear. Okay, so otherwise since here only 90 observations I have, whereas in case of two samples I have more number of observations. So that's why that has some influence on the other. That's why you just clear that. So once you just click on that, select and click on that clear, so the earlier data has been cleared. Okay, so next you repeat the same, that is go to file. Okay, import the data. Once again import the same, because I earlier said all the data is in the different sheets of the same Excel file. So I selected the t-test related file, then open. Okay, so now what we should have to do is in the first part, that is worksheet. So our data is in the other worksheet, not in the first worksheet. That's why, as earlier I had shown, you click on the down arrow mark, all the active data sheets are appear, and with this, now you should have to select the second one, two sample test. Okay, you just click on that. Okay, and just now once again click on OK button. So the data is importing. Now it is imported, but how to structure your data editor sheet in case of this two sample t-test, also for the ANOVA of the variable one by one. Now actually we have two things here. One is the value the variable for which we are interested to compare, that is quantitative variable, because I am comparing the savings of two social groups, scheduled caste and scheduled tribe. Then how to input that into your SPSS or in your SPSS sheet should be look like this. The savings of all the people should be here, or your respondents should be in a single column. Okay, then you have to create one additional variable with a name social group. Here I have called it as only a group. You can call it as social group. Okay, then under social group, since it is a qualitative or a nominal variable, you should have to code. For example, I have coded all the scheduled caste households as 1. So then remaining scheduled tribe households as 2. So for example, if you just drag the data sheet, you will get that is 2. The 2 starts from 91. That means I have 90 households of scheduled caste, then the 90 households of scheduled tribe. And one more point, you should have to be there in your mind related to that. You need not to have equal number of observations for this test. Okay, you might have differences in the number of the observations, 80 or 100 or some differences. No, we need not to bother about that. Okay, so this is the data we have, and that's why you have to structure your data like this. Your testing variable in single column, and you have to group that, and you have to group and name that group as 1 and 2. So after this, again go to analyze button. Then the same selection of compare means, then the independent sample t-test. Independent sample t-test. So in comparing the means of the two populations, actually we have two tests. The one is independent sample test, the other one is matched paired test. Dependent sample t-test, which means the variables which we have selected for testing of the means might be related, dependent, then we cannot use this. So for that we have to use that one, 4 paired sample t-test. This is familiar like this. We are familiar with before and after test. Before treatment, after treatment. Before a particular teaching method and after particular teaching method. That is, we are comparing the performance. So in medical science, before treatment, after treatment. In agricultural economics, in case of that experimental design, for example, before using that particular fertilizer and after using particular fertilizer, and differences in the yield level of that particular crop. So that's why wherever you have that concept of pre and post, before and after, so it means your samples which you have collected are dependent. So that's why then in such context you have to use a paired test. Otherwise, you have to use independent sample test, since the scheduled caste and scheduled tribes populations are independent, not related. Hence, the appropriate test is independent sample test. So, select independent sample test or click on that independent sample test. Again, a new window appears. So, in this, now we have two variables, as earlier I have told you in the variables pane. So, now you should have to put savings by clicking this arrow mark under the test variable. So you just click on that, the say below that you have a grouping variable, because here we have grouped the second variable. Select on this, select on group, okay, and put under that grouping variable here, automatically put the that define group. Coded our groups as one, you just click on define, coded. Otherwise, not coded, you have to enter. You just click on continue. Independent to sample test, one more cell, and you should have to define your groups. Then continue. So once you have continued, now OK button is active. Earlier, before doing all this, OK button was inactive. So now it is active. Okay. So, and if you need some more, again, that gives you the same 95. Okay. Finally, you should have to click on, you unmark that estimate effect size that is not needed in this case, or you need not include for our hypothesis testing. That's why I unmarked that, and click on finally OK button. So once you have click on OK button, so now you have two tables. Okay, the first table, as earlier I have told you that for a single variable you have only one row. Now you have two rows. Okay, because this is related to the descriptive statistical values. In both the cases, we have 90 observations. Their individual means are 2026 already noted for SC households, whereas it is lesser for ST households. And this data is real, not hypothetical, because it is related to one of the works. Okay, so it is 1882. This is the sample observation. That means in our sample, the scheduled caste households are average savings of 2026 rupees, whereas the ST are having only 1118 rupees. So whether this difference is statistically significant or not, so that is given by the next table. So that's why the table is independent samples test. So in this independent sample test, we have two parts. Okay, the one test is related to the variance, the other one is related to the test of equality of the means. Yes, earlier I have told you that all these are all parametric tests. They are based on assumptions. Okay, the first assumption, as already I have told you, that normality, that is the variable which we have chosen, that is savings, is assumed to be normally distributed. The second one is, and the more important one, given in SPSS along with this testing of means, is the variance related test. And there are different variance tests developed by statistician, whereas SPSS gives a 11 C's test. The name of a statistician, it is the 11 C's test for equality of the variances, whether the variances are equal or not. First, the variances are tested, then the means are tested and given in this table. So to test the variance of the variables, F test is applied here. So that's why the calculated value of the F is this. And as usual, this is the probability value. The probability value based on our previous discussion is statistically significant. That means the variations in the savings of these two groups is not constant. There is a significant differences in the variances of the savings of scheduled caste and scheduled tribes. Probably you have seen that from the standard deviation. Okay. So there is a difference, whether this is significant or not, given by 11 C's. So accordingly, now we have two rows. One related to the assumption of equal variance. The other row is related to not assume. If since the probability value of the F or the variance test is statistically significant, in which column you should have to select? Row you should have to select second row, because equal variance not assumed, because the 11th state rejected your null hypothesis of equal variance. So now come to this. This is the calculated t value, and this is the number of the degrees of freedom, and this is the level of significance. So again, the level of significance is 0. The level of significance is 0.001, which is less than the assumed level of alpha of 0.00, 0.05. So we have to reject our null hypothesis of equality of means. So probably from statistics classes, you have noted that the null hypothesis is, that is, mu1 is equal to mu2. Mu1 refers to the mean value of the first population, mu2 refers to second population, or the difference between these two is mu1 minus mu2 is equal to 0. So that's why we are rejecting. That means the savings of these two social groups are not similar, and by statistical descriptive statistics we are noted that, so the SC households are better in savings compared to the scheduled tribe. So that is our final conclusion. And one more point in using these results of any statistical package, as earlier we have noted that they only give the results. The statistical decisions or the results are given, but you have to make your decisions from using this information. So the decision is that there is a significant difference in the savings of these two groups, social groups. That is the statistical interpretation. But practical way of interpretation is that, so the scheduled caste are having more savings compared to scheduled tribes, then you should have to give the suggestions for what to do for making equal among these two social groups in terms of improving the status of or the status or economic status of this scheduled tribes. That is beyond the statistical interpretations. Okay, this is about the independent sample t-test. So then I will take one paid test related data. Okay, so for that we go back to that ಇದೊಂದು ಪೇಪರ್ ಕೊಡಿ ಇಲ್ಲ ಕೊಡಿ ಇದು ವರ್ಕ್ ಆಗುತ್ತೆ ವರ್ಕ್ ಆಯ್ತು ತೊಂದರೆ ಓಕೆ okay. So now you clear that data. Okay, you clear that data. Okay, you clear this data, both you select the two columns simultaneously. Okay, sorry. Okay, or one by one. Okay, now I have to clear this one. We have to repeat that same. Okay, go to file, import the data, then select the Excel file and same one t-test, one sample data. So then you have seen one, okay, paired test related last sheet, paired test, select it and click on OK. So now, so it is the scores of the students, for example, before a particular method of teaching and after that method of teaching. That's why it is the scores before and after or pre and post. Hence the same names are given here. Okay, the same names are given here. But even in case of this SPSS, of course, since I have taken this from one of the books and I have used Stata for this, whereas in case of Stata, I should have to have this in the two separate columns. But whereas in case of SPSS, as earlier I have told you that they should be in the single column. Again, you should have to have the groups, group 1 and group 2, group 1 and group 2. So, and the next procedure is same. So that's why I don't want to get into this part. So only what you should have to do is, or need to do is, you have to use the same methodology. You have a data in a single column, grouping them first and second, and use that paired t-test, select that, and the procedure is same. Okay, hence even interpretation is same. Hence I don't want to get into that. Better I will take analysis of variance, ANOVA and ANCOVA related discussions. ಬೇಡ ಬಿಡಿ ಆಯ್ತಲ್ಲ. Okay. So now let us clear this too. Okay, go to file, open, import the data, Excel. Now I will take, okay, say ANOVA data. Okay, that is the second one, ANOVA data, that is salaries. Okay, you select on that, open. Okay, sorry, I think 1 minute please, 1 minute please. Yet I have not clear. Okay, import Excel, then ANOVA data, salaries, open. Okay, So it is only in the one, okay, salary and occupation. Okay, we just first one itself import. Just click on okay. Okay, now we have here three variables. Okay, one is the salary, the second one is the type of occupation, and the third one is gender. Okay, but for one-way analysis of variance, it is an extension of the earlier and the two means test. Now we have the same mean values. Like here, we have groups of persons who are working in different occupations like financial manager, computer programmer, pharmacist, like this. Okay, so that means we are comparing whether the salary of the pharmacist and the financial are mu3. That is a wrong way of stating alternative hypothesis in case of analysis of variance. Therefore, the alternative hypothesis is at least one mean is different from other means. Okay. So now we have data. Let us take only these two first. We are comparing the salary of the people or selected respondents across the occupation type. So for that, again go to analyze button. Okay. So then go to again comparing means. Compare means and the compare means, and one of the options in that compare means is one way ANOVA. Okay, one way ANOVA. So in this one way ANOVA, okay, one way ANOVA. Now we have salary. Okay, the group is not appear, of course, here that should be comes. Why the group is not appear? Because here we have, it is a string variable which is not coded yet. So that's why it is not appear in our one-way ANOVA tables. Therefore, okay, therefore you should have to go to variable view, okay, and you should have to code that variables. You have to give the name code for or the numerical ones. That's why in case of variable view, the second one is occupation, and under that occupation row, you come to values. You just click on that values column and you will see one dots there in the right part of that cell. You click on that, okay? You click on that. So that is gives you a value label window. In this value label window, okay, you enter the values for them. For example, value 1 is value 1. We are provided value, the one for the first one. What is the first one? That is financial manager. So that is type financial manager there. One for financial manager. So then click add. So then next 2. Okay. Then the name for that 2 is computer program. Okay. Then click on add button. The third one is say pharmacist. Okay. So then click on add button. Okay. So now we have coded them as 1, 2, 3, or we have classified our sample respondents based on their occupation as 1, 2, and 3. So click on OK button. Okay. Now, so in case of this, now this computer taken these variables as that one, and in case of this nominal variable, now we should have to change. Okay, you continue with nominal variable, whether we will see whether our variable appears. Then go to analyze button, repeat the same step, open that one-way ANOVA. So again, it is not. Okay, okay. So then what we should have to do is you have to change it as a numeric variable in case of this type numeric. Actually, it is a string. Go to that type, but type change into numeric. Okay, numeric. Okay, so once you change it to numeric, so that appears in case of your ANOVA table. So which means though that is in numeric form, that is in string form, the important point is even for testing this ANOVA, what you should have to do is that you have to code them. So then you should have to choose that numeric in the second column in the type of the variables. So now once you have prepared your variables like this, the next step is you have to put the salary as the dependent variable. Okay, and this analysis of variance, what we are doing is purely using that basic statistical way of using that extension of 2 means into 3 mean. Whereas we can also do this analysis of variance using regression methodology. So because of that, probably you have seen your dependent and factor variable. But actually in case of two means test, there is no need of that classification. Okay, even for using that analysis of variance in pure statistical terminology without or the non-regression form, dependent independent concept is not required. But we can do also using the regression, because in case of this, the dependent variable is a quantitative variable, independent variable is a qualitative variable. Okay, so in that sense, so it is also a form of a regression for testing ANOVA type of analysis. So then you put this occupation into factor. So that means factor means an independent variable here. So that is a treatment variable. Treatment is the type of the occupation is considered as a factor or treatment. And also I hope that say in case of analysis of variance, that only tells or gives us whether the means of the 3 or more than 3 populations we have selected are same or not. But which mean is different from other is not given by analysis of variance. For example, so finally this ANOVA results gives you if it is statistically significant, for example. So there is a statistical significant in the salary or the mean or the average salaries of these 3 types of occupation. But which say the type of occupation is different from other, whether all 3 occupations are having different and significant salary levels or not, we are not able to answer for these questions using only analysis of variance. So to overcome from this, the statisticians have developed some post tests. They are called as post comparison test or post hoc tests. So there is an option in case of all the statistical packages, including SPSS. In the right part of this, you see post hoc. So that's why you click on that post hoc test. Once you click on that post hoc, you will get several one. Okay, so out of this, you will select any one of that. There is a differences among them with comparing the variances they take. So I will take one popular among them is 2-case method. Okay, so that means they are nothing but multiple comparisons equivalent to our comparing 2 tests, comparing the salary of financial manager with computer programmer, financial manager with say pharmacist and computer programmer. Like this, a multiple comparison will be done using any of these methods. That is called as post hoc one. So there is I am not much knowledge related to that. Only the difference is in terms of measuring the variance. Why the means are different? Because of the variance in the values of the variable we have chosen. In measurement of that variance, these different tests are using different methods. Okay. So as I have seen in most of the cases, in the literature, the Tokay is used, LSD is also used. LSD means least square deviations. That is, that takes the deviations with the least values and calculate the differences and testing the differences. Tokay is the name of the persons, it is given like that. So one Duncan one, that Duncan one is homogeneity test that groups the category into homogeneous. If all are homogeneous, it comes in a single column. If there is a difference, one comes in one column, other comes in other column, like that. So that is homogeneity, based on homogeneity, like this. So there is a difference, that difference only in calculation of the variance. Okay. So now I use 2K, then you just click on continue button. Okay. Once you click on continue button, then you go back to the original window, and in that original window, okay, you can also click on that. And of course, if you need descriptive values for this, you go to option button. Okay. Descriptive, because in case of ANOVA result and post hoc results, mean value, standard deviation values are not given. So to get that basic knowledge or the fundamental information related to that, you better to use the descriptive statistics along with this. So select descriptive, then continue with that, then finally click on OK button. So now you will get the results for this. Okay, sorry. Okay. Probably the code which I have given is not considered. So that means probably it is not. I have, so number code 1, code 2, code 3. You know, I have typed some typographical errors might be there. Okay, because of this, I wouldn't get the result. I will check once again. Okay. Where is that? Okay, sorry, I have lost that data. Okay. So that is because there is no time for that. I have made mistake in typing probably. That's why I will get that result. Otherwise, we will get, so there you will get two results. One is ANOVA table results. The another one is post hoc test results. Otherwise, I will take one more if okay, just a minute. Okay, in the same one. Okay, 1 minute, please. Okay. Okay, it is. Okay. So actually I should have to do like this. Even in case of this, it is an extension, because that file, as earlier I told you, that it is related to Stata. So in Stata, I need not to do all these things. Sorry. So that means even for ANOVA, that should be in a single column. All your values should be in a single column, and your code should be like this. See, also should be in a single column. That doesn't take the values. But whereas in Stata, so that takes, if I given that name and coded it directly, that gives the results. Okay. So as earlier I've told you that I always use Stata instead of this. So that's why I have some mistakes. Okay. So let us assume that. So you'll go back to that. You import that ANOVA table in my original file, that is t-test related file. Okay. Then go to analyze button, then compare means, then one-way ANOVA. Okay. Here savings as a dependent variable, groups as the factor variable. Okay. Sorry. Group as the factor variable. So then same post hoc test. I selected here 2K test. Okay. So then continue on. Finally, I click on this. Okay, the results are given. Okay, probably because of that. Okay. Okay, results are given. Two tables, as earlier I have told you that. Okay, this is the results of analysis of variance, and this is post hoc test of 2K. And here, so these are all the statistics which are required to compute the F test in case of analysis of variance between groups and within groups variations, and their degrees of freedom and means, and the F value. So again, the testing is based on the same calculated value of the F and its significance level. So since the 0.001 is the significance level, and which is again statistically significant, which indicating that there is a significant difference in the savings of scheduled caste, scheduled tribe, and the other group, that is OBC. So I have earlier two groups. Now I have extended into 3 groups. So therefore the savings is statistically significant. But which group is different from the other group? That is done by using this. It is a comparison, comparing scheduled caste with the scheduled tribe and with the OBCs. So here, so now just we have been observed that, okay, actually it is 4, okay, 0.04. That's why there is a significant difference in the savings of scheduled tribe with other 2 social category. But if you take scheduled tribe, so in case of scheduled tribe, there is no much significant difference between second and third, but there is a significant difference between first and second. So that means with scheduled tribe and scheduled caste. And whereas comparing the OBC, so the OBC, there is a significant difference with the scheduled tribe, but not scheduled caste, but not with the scheduled tribe. So that's why by using this multiple comparison post hoc test, you can do this. Okay, so this is testing the mean values of 1 sample, 2 samples, and the 3 sample test. Okay, then the last one, so I will take with a single data, both regression, correlation and regression. Okay, so now open a new one, or with that, go to first file, import from the same folder, Excel sheet. Okay, so now I take the data related to, okay, earnings, okay, wage, okay, related to earnings, regression, earnings, you select that regression and earnings, regression, earnings. Okay, so select that regression, earnings data, open that, then click on OK button. Okay, this is related to the earnings of the persons, that is the salary or the wage, that depends upon assumed year on 2 variables. The one is their level of education and the experience. Okay, that is the amount a person earns theoretically in the endogenous theories in our development economics. That depends upon some of the variables. The 2 most important variables are, the one is education, the other one is experience. So both are measured in quantitative terms. So for example, the level of education is the number of the years they have attended the school or the college. So for example, 16 means 16 years of level of education. So then this is the number of the years of the experience, 22 years, 21 years, 13 years. So we know that as the experience increases, salary also expected to be increase. So that's why our purpose is to measure the impact of the level of education and their number of years of experience on the wage rate or the salary. So that's why this is a context related to application of regression analysis, that is cause and effect type of relationship. And even before that, using that regression equation or regression analysis, we can also do a correlation analysis among them. means whether if the variables are having correlation, then only the one variable impact on the other variables. If the variables which we have chosen are not at all related, then there is need not to be or even not at all a causality among the variables. So that's why for the same data, we can also do that correlation analysis. So for example, to do, oh, sir. Yes. Yeah, sir. Yes, sir. Yes, sir. Before that, we have to change that. If it is nominal, yes. Earlier I have told you that we first have to confirm that. Okay. Sir. We should have to change into a scale variable because all these three variables are scale variables. Scale, that is the data preparation. Okay. So that data preparation includes all those things earlier we have discussed. Okay. So because of paucity of time, we need not get into that. Okay. Then go to data view, analyze. Then you have a button called correlate. Correlate. Okay. Correlate. So put your cursor on correlate and select bivariate. Bivariate means comparing the correlation among the two variables each time. So select on bivariate. Okay, then click on that bivariate and you will get a dialog box like this. All the three variables are in that variable pane. And now let us take two variables. That is the correlation between earnings and level of education. Correlation between earnings and level of education. So, and even you can take this one, but that gives you in a matrix form. So I put all the variables in a variables box and then you click on OK button. And here, since all the variables are quantitative, metric variables, scale variables, Pearson correlation is by default. So if they are ordinal variables, you have to use Spearman correlation. And more ties are there in your data, then you have to use, that is the tau, Kendall's tau one. Okay. So now you just click on OK button. Okay, if you just click on OK button, this is a correlation matrix. Along with the correlation value, the significance level also given below that. Okay. For example, so you need not to consider the values above this diagonal, and all the diagonal values are 1, that indicating one of the properties of the correlation, that is correlation among the variables themselves is 1. Correlation between x and x is 1. So that's why you just take the value below this. For example, all the number of observations are 590 observations are here, 40 observations we are here. So it is the correlation between, okay, earnings and education. Earnings and education. So the value of the correlation is 0.437. So in terms of percentage, it is 43.7. So, and the asterisk is given above this number that represent the level of significance, and below that it is given at say 1% level. So which indicate that there is a significant correlation between, statistically significant correlation between the level of earnings and the level of education. And moreover than this, the correlation between these two is positive. Though the sign is not given, as all of us knew, we should have to treat it as plus. That's why there is a positive correlation between level of education and earnings. When the level of education increases, the level of earnings also increases, and that relationship is statistically significant. Okay, and it is positive. So that means by using this correlation analysis, we are able to answer for 3 questions. The one is whether the variables are related or not. The variables are related, and the kind of relationship is positive. And the one more is the magnitude of the degree of the relationship. The degree of the relationship is almost 44%. 44%. But as all of us knew that this correlation does not imply causality. So that means, so just by observation of this correlation value, we cannot say education influences on earnings. So to answer for this, we need to go for dependence techniques. As already we have noted, the most popular dependence technique is regression analysis. Okay, so that's why if we are not clear about the variables we have and the type of the relationship among those variables, in case of regression analysis, one of the preliminary step is we can use correlation to identify whether the variables are related or not. And These are all a testing or formal test, and one graphical one is scatter diagram. Using scatter diagram, we are able to know whether the variables are having a pattern of relationship or not by observing that pairs of the values. Okay, so if you go to that say graphs, so in that graph button you have a legacy of graphs. In that legacy there is a scatter diagram. You just click on that scatter diagram, dialog box opens. So in that you have to put one variable in the y-axis, one variable in the x-axis. You will get a scatter diagram for your selected variables. So then the last, so go to that variable view. Okay, variable view. Okay, then go to analyze button. Then below that correlate, now we have a regression, because there are different forms of regression. All that regression forms are given here. So a linear regression, then the least square method, which is partially estimate, that is binary logistic. Earlier I have told you that where the dependent variable is qualitative, then you should have to use logistic regression. Then if you have pure nominal variables, so we can also use that logistic regression, that is called as multinomial logistic regression. The regression has different variants. Okay, the most popular is that variable, quantitative variable is a dependent variable. So you select that is linear regression. Okay, once you click on that linear, okay, then the linear regression dialog box opens. So in that you should have to only do select a dependent variable and independent variable to respective cells. Dependent variable out of these three is earnings. That's why put that earnings as a dependent variable in the dependent variable cell. Then the remaining two are independent variables. So simultaneously not, okay, select that education and put it under the independent variable box. Okay, then experience also under the independent variable box. So that means now we have a dependent variable earnings and the two independent variables education and the level of experience. Okay, so then if you need some more say additional statistics, so go to statistics before getting the results. For example, if you just click on that statistics button, then these are the different one. Okay, estimates, that is the regression coefficients by automatically it is given. Model fit, R square value is automatically given. If you need some more additional statistics, for example, collinearity statistics we have required, diagnostic. So because this regression analysis assumes several assumptions, it based on assumptions like the error term is normally distributed. Then the mean value of the error term is 0. There should not be any variability in the disturbance terms, homoscedasticity assumption, no autocorrelation or serial correlation. So like that, we have different kinds of assumptions. So whether that assumptions are holds good or not, we need to test them. They are called as diagnostic tests, regression diagnostic tests, or model adequacy tests they are called. So one among them, of course, given in this statistics is collinearity diagnostics. For example, if the serial correlation problem is present or not, so that is given by Durbin-Watson test. But of course, we cannot use here, it is a cross-sectional data, because this problem is only found in case of time series types of data. So that's why out of this, I select only one along with the by default is collinearity diagnostic I have selected. Okay, then continue. So then if you need plots, you of course you need this. Okay, that is, this is the predicted value of your variable. This is residual value, that is the error value, and this is the okay the actual value. It is the standardized residual value, it is observed value of the residual. This is the other values, residuals, ID, and so on. So they are required for post-estimation analysis. So therefore, I don't want to get into that. Okay. So then click on continue button. Okay. Then if you select click on option, okay, that is by default, it is 95% confidence and so on. We need not to make any changes there. Okay. So then finally click on OK button. Okay, out of the different options, I have selected only collinearity diagnostics. That's all. Okay, then click on OK button. So then the results are given. This is the model summary. So in this model summary, here we have the multiple coefficient of correlation. It is multiple coefficient of correlation because we are calculating correlation among 3 variables. Okay, that's why now we call it as a multiple correlation coefficient. This is R square, goodness of fit of the model. It is adjusted R square that taken into account the number of the variables or degrees of freedom in calculating the goodness of fit, and it's the standard error of the estimate. Okay, that is one more model adequacy test or model fit. Okay, so what this means is that, okay, in this case 19, okay, it is 0.197. Okay, in terms of percentage, 19% of the variation in the salary in our data is explained by these 2 variables, because out of total, okay, R square value lies between 0 to 1. 0 represent the model doesn't influence anything on the dependent variable. 1 highest influence. Okay, therefore it is only 19.8 or 18% of the changes in the salary is explained by level of education and the experience. That is the way which we should have to interpret. Okay, so then if you come to this, and that is not much important here, because in case of only SPSS, we got analysis of variance along with the regression, and from this we need only F value and this. And the meaning of this analysis of variance in case of the regression analysis is that say we have 2 kinds of tests in regression analysis. One is called as individual regression set, whether the education influences on the earnings individually or not, whether the experience individually significantly influence on earnings or not. That is called as individual significant test. And the one more is whether simultaneously, that means in combining the effects of these 2 variables, independent variables, whether they have a combined simultaneous effect on the earnings or not. That is the another way of testing hypothesis. And here F is used for this. That is overall significance of the variables. Overall significance of the variables. So since the F value is statistically significant, so both variables have a significant influence on the earnings. That is the way which you should have to interpret that given F and the level of significance of that F value. And the last part is so related to coefficients. So okay, coefficients. Okay, in this coefficient, that is the main important part in case of regression analysis. Okay, and you should have to, of course, in SPSS that gives 2 estimates. One is standardized estimates, the other one is unstandardized estimates. You should have to focus only on unstandardized estimates. For the effects, actual effects, relative comparison of that, we have to use standardized or the beta coefficients, but in practice, unstandardized coefficients are used. And these are the estimated coefficient, estimated values, and their t values and the level of significance. So first, what we should have to observe in case of this coefficient value is that whether the coefficient sign type of effect is according to our expectation or not. Because in most of the cases, the cause and effect or the regression analysis used for confirmation of our relationship of the variables we have chosen based on our theoretical underpinnings. So from our own observations or theories related to education or education economics in our branch of economics. So as education increases, we are expect salaries also increases, and the experience and the salary is also positively related. This is our prior assumption. Even in our hypothesis, we should have to make that. That is, education and experience have a positive influence on earnings or the salary. That is our hypothesis related to this particular context. So that's why first you should have to look whether the signs are positive or not. So since both the variables have a positive sign, that's why these results are confirm our theory. There is a positive effect of these 2 variables on the salary or the earnings. The second one, we should have to come to the magnitude of the values. That is the numerical values magnitude. For example, if this, since we have measured education as number of years, if there is 1 year increase in the education level, If a person has an additional year of education, on the average, salary is increases by or expected to increases by, for example, if it is measured in 1,000, so I have to interpret it as for every additional increase in the level of education, the salary is expected to increase on the average by 2,966 rupees. That means for additional 1 unit increase in the explanatory or independent variable, this value gives the change in the value of the dependent variable. So that's why for every additional 1 years of education or extra year of education, the salary of the persons on the average increases by 2,900 and plus. Okay. And whether it is statistically significant or not, though it has a sign which we have expected and increases by some amount, but whether it is statistically significant or not, you should have to look the significance value. So 0.0001, which indicating, so the salary is not increases with the level of education, but also it is statistically significant. In the same way, you should have to interpret this result. So for 1 extra years of experience, there is a 298 rupees increase in the salary, and that is also significant, but it is at 5% of level of significance, whereas this is at 1% level of significance. So, and as earlier I have told you that there are different assumptions, several assumptions which are required for this use of regression analysis. The one is that collinearity or multicollinearity problem, and of course, so here what you should have to look is that these values. Okay, this is the variance proportion or conditional index, and there is actually one more is that VIF is given. Actually, that is the most popular diagnostic test, variance inflation factor. The value of the variance inflation factor on the average or for each of the variable should not be greater than 10. If the VF value is not greater than 10, there is no multicollinearity. So if there is a multicollinearity problem, means if the independent variables are collinear each other, so then our results are not reliable. We will have wrong signs for our variables and we will have several problems. Even our t-test is not appropriate, or formal classical hypothesis testing are not appropriate. Like that, there are various implications on that. So, okay, you should have to go through all those things. Okay, this is the way which we can use SPSS for analysis of variance. And we can also extend this by including a qualitative variable. For example, along with this, if I include gender, the salary is not just differences among the respondents, not just because of having education or additional year of experience, and also it is difference among male and female. So then the male and female or a gender is a qualitative variable, then those models in statistics are called as ANCOVA models. ANCOVA means having both qualitative and quantitative explanatory variables. In case of regression, so that gives a same kind of results, but the interpretation is different. Okay, so since paucity of time, I am unable to get into that. So because of some technical problems, we have some interruptions in between that. So I sorry for that. Non-parametric. Okay. So I will first check whether I have data. Okay, I think I have a chi-square related data is there in my table. Okay, so you clear that. Go to new page. Okay, go to file and import, then Excel. Yeah, okay. Chi-square independent test. Okay, one file is related to chi-square, the sheet is related to chi-square. Okay, you just select on chi-square independence test, chi-square, and open that. Okay, this is okay. The data you just only one sheet. Okay, you just click on OK button. Okay, this is a data related to some other work. It is willingness to pay. WTP is willingness to pay. Okay, so and that willingness to pay is coded 1 represent. So it is related to the willingness of the people, whether it is for charity, for example. If you ask people to give charity, some are saying yes or not. No. So that's why willingness to pay. Or in case of our own discipline, we have environmental economics, natural resource accounting. In case of all that, so whether the people are ready to pay for conserve the natural resources or not, like our own lake, Kukrali Lake in our university, whether people are ready to pay or not. So that's why it is yes or no, a qualitative variable which is coded here. Okay. So then, of course, one more is their gender. Okay. For example, now my purpose is whether the gender and willingness to pay is associated or not. So now I am using the word association, not the relationship. Because in case of a quantitative variable, we have to use relationship. To measure the relationship, we have to use relationship. But if our variables are qualitative, non-metric variables, the better word for measuring the relationship and whether that relationship is significant or not is association. That's why whether there is an association between willingness to pay and gender, or even we can extend that whether the gender affect on willingness to pay or not. Okay. So as we were noted in our previous theoretical discussions, okay, if we have two nominal variables, then testing a hypothesis related to the association of the two nominal variables is chi-square test. Okay. So now I use chi-square test for that. So the chi-square test is one among several non-parametric tests. So there you are noted that MW test when the variables are ordinal, KS test. So and also we have an analogous to every test of parametric. For example, in case of two variable parametric test, the analogous to that non-parametric MWRKS. For ANOVA, we have an equivalent test. We have an ANOVA, an equivalent test. So that is, say, the Kolmogorov, Simrao test also, and also KW test, Kruskal-Wallis test. So we have also repeated ANOVA. Repeated ANOVA is related to, say, if the variables are dependent, like paired test, two variables. Repeated ANOVA means it is a test for dependent more than three variables. So repeated ANOVA is a parametric test. Friedman's test in case of a non-parametric test. Likewise, we have every test equivalent to this parametric test in non-parametric test. Okay, one among them is this chi-square test. So go to analysis of variance. Okay, go to ANOVA. Then to do this, okay, you need not go for that non-parametric test button here. Okay, one non-parametric test. So for example, if you put your cursor on non-parametric test, okay, you will see like this. It is for one sample. It is for independent sample. It is for repeated sample. That is equivalent to independent sample t-test, paired sample test. That is the names. If you just put your cursor on legacy diagnostic, then the legacy diagnostics are this. Okay, KS test, as earlier I have told you that this gives you MW test and so on. Okay. So, okay, since here we are using chi-square test, I hope you know chi-square test has been used for two purposes. One is goodness of fit. The other one is this measuring association, test of independence. Now I am taken only test of independence. So that's why the test of independence can be obtained from this cross tabulation in descriptive statistics. That's why put your cursor on descriptive statistics, then go to the cross tabulation. Go to cross tabulation. Click on this cross tabulation. That means you should have to represent one of your variables as the rows, the other one as columns. And to use all these tests, one of the important point which we should have to bear in your mind is that you have a classification of a variable. At least we must have to have two classification of each of the variables. If you have only one, for example, earlier experience, no classification. It is a quantitative variable. No classification is there. We cannot do this for that quantitative variables. That's why we have a qualitative variable or an ordinal variable, because in all these cases, our variables are further classified. Okay, only for those we can do this non-parametric test in general, including this one. Okay, so now I take, there is no any rule you should have to take WTP in row or the gender in column. That is left to you as your convenience. I take the WTP, willingness to pay, yes or no, into as a raw variable and the gender as a column variable. Hence, here in my case, I have only 2 rows, 2 columns, because my classification is gender is classified into only 2 categories, and as well as the WP is also 2 categories. So then you click on statistics. Otherwise, that gives you only a cross tabulation. Okay, that gives the frequency that appears with that each cell is given to you. But we need along with this whether that is statistically significant or not. So click on that statistics. So in this statistics, now you should have to click on chi-square. Chi-square. Okay, the first one, chi-square. Okay, and if your variables are nominal variables or ordinal variables, there are specific non-parametric tests. You can also use this. Okay, in first one lambda coefficient, I have told you that, and we have a mix of both nominal and ordinal variable, mix of nominal and ordinal. Then we have to use that commerce V, phi and commerce V. So one nominal, other one is ordinal. If both are nominal, we have to use chi-square test. Okay, so I here use chi-square test. Then click with the continue button. It is under statistics option. Then next you click on cell button. So in this cells button, okay, I hope you might have seen in some tables related to this chi-square test, along with frequency, we also observe percentage of that cells, isn't it? Along with frequency, percentage. If you need percentage, then you click on these cells. For example, in this case, okay, in this case, only observed is given. Okay, observed, I hope you know the basics of calculation of this chi-square test. Observed, expected. So if you need expected frequency, you can click on that, but that is not required. But therefore, in percentages, in the second part, percentage. In percentage, whether you need percentage for raw variable or column variable or both, or even for total, you decide. But if you select all, the table become bigger, and also you will have several values within that. So I just select only a cells percentage only for the raw variable, only for the raw variable, for example. Then click on that raw button. Okay, then continue. Okay, so then what I have done thus far is that within this I have selected statistics, under that chi-square and cells cross percentages. Then finally click on OK button. And also if you need, for example, a bar chart for this, you click on that display bar chart, clustered bar chart, clustered bar chart. For example, let us select that also, select that also. Okay, so then finally click on OK button. Okay. Okay. This is the table and the values of the test. Okay, and this here, as earlier we have selected to represent WTP row wise, that's why row cells are represent this, and the column is gender. So now you have to interpret like this. Okay, now 0 represent not willing to pay, 1 represent willing to pay. Okay, so the gender 1 is male, 2 is female. So 1 represent, okay, 16 males are opined or they responded not willing to pay. Okay, out of 21, or in other words, out of 103 respondents, 21 were responded not willing to pay, whereas 82 were responded, they are willing to pay. Out of this, if you come to gender, Out of this 21, okay, 16 males were not willing to pay, whereas only 5 are not willing to pay by the female category. In terms of percentage, 76% of the gender out of 21 are not willing to pay, and whereas 23 out of the female which are not willing to pay. So like that you should have to interpret. Okay, but for test is this, you should have to take only Pearson's chi-square value. The chi-square value is 0.000, and so it is degrees of freedom is 1 because 2 minus 1 into 2 minus 1, it is 1 into 1, 1. So, and this is the value. The value now, of course, in all our earlier examples, the statistic was statistically significant. But whereas in this case, not significant because the value is greater than 0.05 level. So therefore, there is no statistical association between the willing to pay and gender. Willing to pay and gender. So that is, so you can extend this. So instead of 2 rows and 2 columns, even 5 rows and 5 columns, finally you will get only one value of the chi-square. Okay, this is related to measuring association or using this one. But whereas if in case of goodness of fit of use of this chi-square, okay, that is used like this. In case of, for example, marketing analysis, okay, there are some predetermined values are known like this. Existing market is shared among the 3 companies. Okay, 50% with A company, 35% with B company, okay, then remaining with other companies. So now a company wants to know, because of a new advertisement program, whether that is gained in the market share or not. So that's why in that case it has to collect the opinion of the people or the customers, and he has some data related to that. And now it has to check whether the pre-assumed theoretical market values or the market share values are same with the observed one or not. That is called as goodness of fit. Means we have assumed some values which is already existed and comparing with the observed values. That is called as goodness of fit. So, but the most popular out of these two is this association test or measuring independence of the qualitative variables using chi-square test. So, and of course, you have to use that non-parametric test for all other tests and which is similar. Okay. Okay, I think already we have crossed say half an hour for the given one. Okay, if there is any questions, we will have time for that also. Okay, now, okay, no problem. Okay. So now the session is open for discussion. If you have any clarifications or queries or any additions to my talk, you can free to ask or add to my. Any questions? ಅಲ್ಲಿ ಬಹುಶಃ ಅದೇನಾರು ಇದ್ರೆ ಇಲ್ಲಿ ಶೇರ್ ಅವ್ರೇನಾದ್ರು ಅಲ್ಲ ಚಾರ್ಟ್ ಇಲ್ಲಿ experience or hands-on experience. Okay, if you have, of course, even in further days, since you are all in this college, if you want some more classes, I will come and take the classes. Yeah, yes, please. Yes. In down. Scroll down. Okay. So the difference between those two is the observed frequency is the data which you have collected from the respondents. Okay, for example, there 16, the another value, they are observed frequencies. That means that is observed from the field. Okay, so therefore, that is called as an observed frequency. The expected frequency is a theoretical frequency. For example, related to that willingness to pay between gender and between male and female, if 50% of the male and the remaining 50% of the male having the same opinion, then naturally there will be no difference. Okay, if our observed values are equivalent to that 50 and 50, then the difference is less. In such a case, we are unable to reject our null hypothesis of the same opinion regarding the question. So, if the observed frequencies are much deviated from that 50%, so in case of two groups, in case of three classifications, 33, 33, 33 add. So that is theoretical one. So that's why theoretical one is, it is 0 to 100%. Maximum is 100%. Okay, we have to divide that particular opinion based on that classification. If there are 4 classifications, 25, 25, 25 are the theoretical frequencies. If our observed frequencies are equal to that one, no difference or no association. So if there is, we have an association. That is, observed one is the data which you have collected from the respondents. Theoretical one is, it is an equal partition of that in the total of 100%. That is observed and theoretical are expected. Any more? Scroll down there. No. That is. Okay. And also, from my side also, I thank you all because your patience listening from almost 3.5 hours. So, and also I am grateful to the St. Philomena's College and also Venugopal for inviting me and share my little knowledge with you in this morning. Thank you. Thank you, Anand.
Accepting your invitations and come to this stage and explain statistics. Statistics is unstoppable things. It will go on. So that this is a primary session. So in the future, we are going to have a few more sessions with you. And the next any things happen in the college. So we're definitely going to have you, sir. It's our pleasure to have you in this FDP, 6-day national level FDP. Thank you, behalf of the college as well as the department, sir. Thank you. So tomorrow we have another last day session. So all of you be there, and we have lots of things in valedictory as well as feedback, everything. So based on the attendance, whatever we have taken from the day first, we are going to distribute the certificate. Please don't do absent means your present is very important in the terms of giving the certificate and other things. Okay, thank you. We are going to wind up today's sessions. Thank you all.